My research is in vision science and in particular computational vision, which is about trying to get computers to see, sort of like the way we see. We use our eyes as our primary source of information about the world. We'd like to be able to endow machines with a similar capability. So prior to go in for a major surgery, typically there's some sort of diagnostic imaging that takes place, say X-rays, MR, CT. Not only are these images used for diagnostic purposes, this imagery is actually used to develop a so-called surgical plan. Now, fast forward to the day of the surgery. The surgeon still has the surgical plan available to them, typically on a video display, say someplace above where they're working, and down in front of them there would be the patient. And guess what? The geometry, the layout of the organs in front of them live is very different than those captured, say, in the preoperative imaging. So the surgeon has to do this very difficult, live, in the moment, transformation between what they're seeing in front of them on the operating table and what they see up here in the video display. Of course, surgeons can do this, they're very talented people, but it's a very mentally demanding task. So one of the things that we're trying to do with our computer vision technology here is to install video cameras overlooking the surgical scene, as it were, to reconstruct its 3D layout live and then compute a transformation that automatically aligns what they see in front of them to the preoperative imagery. Again, surgeons can do this, they do it every day. We want to make their lives a little bit easier so they can be more productive and have easier lives in their workplace. Currently, surgical robots are largely teleoperated systems, and what I mean by that is they're basically driven by human surgeons. We could actually use that same 3D technology to provide robots with a degree of autonomy. So as a starting point, say relatively routine portions of a surgery could actually be taken over by a robot surgeon to once again decrease the load on the human surgeon.